Let's take a look at this example. This time we have voltage source, we have 3 resistors, and we have ground connected to point C. We have to find voltages between points AC, DA, BA, ED, and EA. The very first thing, we're supposed to measure the voltage between every point with respect to C, not to the negative terminal of the power supply, respect to this point. Before we are going to find any of these voltages, we're supposed to find first the direction of the current. This is the positive terminal of my power supply, and this is negative. As we mentioned before, we use the conventional current flow. We assume that current flows from positive terminal to the negative. Remember, anytime current is going to enter the component, in this case we have resistor, is going to label, just imagine that current is going to label the input by positive sign. When current is leaving the component, leaves the negative sign. Again, current is going to enter to this resistor from this side, that's why I'm going to write positive over here, and is going to leave, I'm going to write negative over here. Current is going to enter this resistor from this side, that's why I'm going to have positive over here and negative over here. Next, I'm supposed to just add the voltages together. VA, voltage between this point and this point, is nothing else, just the voltage across resistor R1. That's why I'm going to say that VA is equal VR1. One more time, if you are going to connect voltmeter between these 2 points, you are going to measure voltage across this resistor, which is equal 30 volts. That's why I said VA is equal VR1 equals 30 volts. Next, we have to find VB. Please notice that voltage between point B and C is again voltage across resistor R1. That's why VB is equal, again, VR1, which is equal 30 volts. Why positive? Because I'm going to the ground and I'm seeing positive sign first. That's why my voltages are positive. VC. Point C is connected to the ground. Remember that ground has always potential 0 volts. That's why I'm going to write 0, because point C is connected to the ground. Ground is representing 0 volts. Next, point D. VD, voltage from this point to this. I have to go from D to C. What I'm going to see first? Negative sign. That's why I'm going to write VD is equal to negative VR2. One more time. I'm looking for the voltage from this point to this. C is my reference. What I'm saying first? Negative sign. That's why I'm going to write over here minus 20 volts. VE. VE is the voltage between this point and C. I have to go from E to C. What I'm saying first? Negative sign. That's why I'm going to write VE is equal negative VR3. And I'm keep going to C, and I'm seeing one more time negative, but this time VR2. And I have negative VR3, which is equal 50, negative 50 volts, minus VR2, which is equal 20 volts, which is equal negative 70 volts. This is voltage at point E. Vf is basically the same because F and E, this is the same point. That's why I'm going to write one more time. VR3 minus VR2 is equal minus 50 volts minus 20 volts equals minus 70 volts. We found voltages VA, B, C, D, E, and F. Next, we're supposed to find these voltages. VAC. VAC. Voltage between point A and C. Anytime you see expression VAC, you're supposed to understand this is nothing else than the difference between voltage VA and VC. We said that VA is equal 30 volts. That's why I'm going to write instead of VA 30 volts minus VC we said is equal 0 volts. That's why I'm going to write over here 0 volts. 30 minus 0 is equal 30 volts. VDA, voltage between this point and this point. This is nothing else, just VD minus VA. VD we said is equal negative 20 volts. Negative 20 volts. VA is 30 volts minus 30 volts. Minus 20 and minus 30 gives me minus 50 volts. My VDA is equal minus 50 volts. Next I have to find VBA. VBA is the voltage between point B and A. This is VB minus VA. We said VB is equal 30 volts and VA is equal 30 volts. So I have 30 volts minus 30 volts is equal 0 volts. The voltage between these 2 points is equal to 0. It makes sense because we have no resistance. Remember the formula for voltage says voltage is equal current times resistance. But if there is no resistance, means resistance is equal to 0. 0 times anything gives me 0. That's why my answer makes sense. VED is the voltage between point E and D. So this is nothing else, just VE minus VD. We found that VE is equal minus 70 volts. Minus VD is negative 20 volts. So we have VED equals negative 70 volts. Negative times negative gives me positive. Some people say, why I put this negative inside of the parentheses? Because my formula says I have to subtract from VEVD. So this negative sign comes from the formula. This negative sign comes from my calculations for VD. I get minus 20 volts. These two signs multiplied by each other are going to give me positive sign. Minus 70 plus 20 gives me minus 50 volts. This is my voltage VED. VEA is nothing else, just VE minus VA. VE minus VA. VE is equal minus 70 volts. VA is equal 30 volts. So I have minus 30 volts equals negative 100 volts. VEA is the voltage across the voltage source. But this time we have to go from E to A. That's why we have negative sign. That's why we have negative 100 volts. And these are the solutions to my problem.